Good morning, ladies and gentlemen. I am the almightyzentaco, and today we're going to be learning about a concept called subpixel movement. Alright, so we're going to go ahead and start a new document. And this one's not going to be too fancy in the graphics department. Anyway, first thing we need is an active object. This is going to be our player. So I'm going to name this player. I'm going to go ahead and throw some art in here just because I'm a little bit anal about having some art. Okay, now that I have that completely superfluous thing out of the way, what is subpixel movement? Well, I will show you by example. So, let's go ahead and throw in some keyboard events here. We will do a repeat while pressing right and a repeat while pressing left. I'm going to copy, paste, and modify that. So while we move right, we are going to set the position of this object, of this player object. We're going to set its X position to its current X position plus a value. So let's just make it by default 1. And then we're going to drag this down here and edit this, and when we hold left, we're going to subtract 1. So what this will do is this will make the, when we hold in these buttons, this object, this player object here, is going to move at 1 pixel per game loop. So let's check it out. Okay, so there you go. You know, it's it moves, but it really doesn't give us a lot of control. That without subpixel movement, all we can do is put in whole numbers here for the change. So the rate of change can never be less than 1, and it can never be between 1 and something else. It's always just a whole number. Like it can't be 1.3 or something. It has to be like 2. And so this means that we do not have a lot of fine control over how our objects move. And to fix that, we use something called subpixel movement. Now, you might think, why can't I just go in here and do the rate of change smaller than 1? So let's find out what happens. Let's say if we make the X position change to the X position plus 0.5, you would think that that would move at half of the speed of 1 pixel per game loop. But that is not what's going to happen. So I'm holding right now, and nothing is happening. I hold left, and it moves at what appears to be 1 pixel per game loop. Now the reason this happens is XY coordinates in Fusion are floored by default. And what flooring is essentially just rounding down. So that means if I have it at 0, when I'm trying to move right, I'm trying to move at 0.5. It's going to round that down to 0 until it gets to 1. So 1 it will move, but at 0.5 it's not going to move anywhere. Now the reason it moves left is because we're going negative, so it rounded that down to -1. So the way we fix this is we need to have a variable. We're going to put it in here on our object, our player, and we're just going to call it xpos. And this is going to be the X position variable. We're going to set the X position of our player to the value of xpos. Now the reason we're doing this is because alterable variables or alterable values in Fusion can be floats. A float is a decimal. That means that the rate of change now can be less than 1. So what we're going to do is insert an always event. And we are always going to set the position, the X coordinate of this object, to the value of xpos. And then when we move right and left, we're going to modify xpos. We will just add to xpos. We're going to add 0.5 when we go right, and we're going to subtract the 0.5 when we go left. So let's go ahead and look at that. Okay, now as you can see, we do have subpixel movement. We are moving at a rate slower than 1 pixel per cycle. But there was a problem. The character spawned at the left, and the reason that happened is because we were always setting his X position to the value of xpos, and initially, not initially, that's not a word, xpos was 0. So what we want to do to fix this is at a start a frame event, so throw 1 in. Let's do start a frame. We want to set the value of xpos to his X position. That means that wherever we put him in the frame, at the start of frame, it'll grab his position, throw it into this value, and then it'll update. So he will be drawn from that position. All right, I'll run it. See, he's right there. Now, when we use subpixel movement, we can do all kinds of stuff. We can accelerate and decelerate. Right now we're just using a linear rate of change, so it's actually not even changing. It's just moving him, by the same. We don't have any acceleration, so we're going to go ahead and add that. So we're going to do that by creating a new value. We're going to call this x speed, xspd, and what we are going to do is here we're in the always event where we are modifying his position. We are still going to set his x position to xpos, but we're going to modify xpos. So we're going to always set xpos to the value of xpos plus the value of x speed. And then we're going to, as we did before, we're setting the x position to xpos. Now over here, where we are moving right and left, we are not going to add to x position. Instead, we are going to add to x speed. And we're going to make that something like 0.1. All right. Well, he just flew off the screen. Hold on a second. What did I do wrong? Oh, this is still xpos. All right, x speed. There we go. So now when we're holding right, we are adding to x speed. When we hold left, we are subtracting from x speed. You could also take that value and put it into an alterable value, and so you could modify that on the fly. Right now it's hard-coded at 0.1, but this is just an example. All right, so as you see, he can slide all over. Now when I let go, he still moves. That's because we didn't have a decay for his x speed, which is something we're going to need to put in if we want this to not feel like he's on ice. And you probably don't. So let's go ahead and do that now. We're going to do a keyboard condition. We're going to repeat while key is pressed, right and left. We're going to negate both of these. You can do this lots of different ways. This is just the easiest way. This is essentially saying when the user is not holding right or left, so he's not trying to move, we are going to then set the alterable value of x speed to the value of x speed. And we're going to multiply this by a decimal. We're going to say 0.9. That's our decay. So when we let go now, see, we let go, our dude just slows down. Now, there is currently no limit to the x speed. So we need to probably modify that so that it clamps. We don't want to have them go too high. So under the always event, we're going to do that right now. We're going to always set the alterable value of x speed to max, which will give us the max between two values. Okay, so we don't want him to go lower than probably -3. So we're going to say max -3, and then comma, and we're going to grab the value of x speed. So we are clamping that to prevent him from going below -3. We just need to copy this event and modify it. Now we're going to do something called min, which will always return the minimum, or the smaller of these two values. So we will make that +3. So now that should clamp it so that he will not go faster than 3. That would mean, like, if you think about this logically, if x speed gets over 3, it'll give us 3. So same with this, just the opposite. If it gets, is all give us the max. So if it goes smaller than -3, then it will give us -3. Let's check that out. Yep, our movement is now minimized. Okay, so that is the very basics of the concept of subpixel movement, but we can use this to create a platformer, which we're going to do that right now. So I'm going to insert another active, nope, not an active, sorry. I'm going to insert another backdrop. Where's the backdrop? Sorry, I just woke up. I'm a little tired. There's that slurp for my fans and detractors. I know some people like it, some people hate it. Why don't you leave a comment down below? Let me know how you feel about me slurping on my tea. so good. You gotta try the vanilla chai. All right, so we need to make sure this is an obstacle. Let's go ahead and do that right now. Boom, obstacle. Now this is gonna be a tad bit more complicated, so we're gonna start simple. We need another variable here. We're gonna need two more actually. We're gonna need y pos and y speed. So go back to the start of frame event. We need to make sure that we plug in his y position into y pos, otherwise he will be automatically set to 0 or whatever the initial value you have set for y pos. So always set, or sorry, start of frame, set the value of y pos. Set y pos to the value of his y coordinate. Excuse me. Okay, so that should work. Now, on the always event here, we need to add gravity to his y speed. So we need to do kind of exactly what we did before. We're always going to set his position, his y coordinate, to the value of y pos. Now we need to modify y pos, so we're going to go and always set y pos to the value of y pos, and we're going to add the value y speed. We need to do one more thing though. We need to add gravity to y pos, because y pos, or sorry, to y speed, because gravity constantly pulls things down and it accelerates. So we need to do that. So we are going to have the alterable value. We're going to add 0.1 to the value always of y speed, constantly pulling it down. Let's take a look. Let's look again. Let's put him a little higher up so we can get a better feel for how that works. Now you could, instead of hard code, yeah, it works great. You could, instead of hard coding that 0.1, we could create a grav value and allow us to change the rate of gravity on the fly. Unfortunately, Fusion does not allow you to put alterable values as floats at the beginning, so you have to do something like set it to 100 and then divide it at the start so you can get a fraction. But I'm not going to do that for this example. All right, so here is going to be a little more complicated. We're going to use loops to create a platform engine movement here. So all this stuff here on this always event, we're going to do in loops. We can delete all of that. That needs to go bye-bye. But what we're going to do in this always event is call a loop. So go down to the special conditions and go to fast loops. We're going to do start loop. And we're going to call this down_move. And we're just going to run this loop one time. Okay, so we're always going to run this loop once. All right, so what we're going to do is we need an on loop event. So on loop down_move. So what we're going to do on the down movement is all the stuff we did up here on the y. So we're going to set the alterable value of x speed to the value of y speed to the value of y speed plus 0.1. Okay, so we're going to accelerate the downward movement. Then we are going to set the value of y pos to the value of y pos plus y speed. And lastly, we're going to set the y position to the value of y pos. All right, let's make sure everything's in the right order. So first we are doing the acceleration on the y, then we are updating the y pos value, and then we are setting the y position to y pos. So that is correct. So now that means that every time this runs, it is going to essentially do the stuff it was doing in the always event. It's going to update that y position and move it down. Now we need to find out if something happens on this loop. And let's go ahead and throw in an on loop again. Say move_down. Oh, it's down move, sorry. Wait, which is it? It's down move. Okay. So down_move. All right, so we also want to find out if our player here is colliding, if he is overlapping a backdrop. So if that happens, if he moves into a backdrop, then we're going to run another loop. We're going to call this loop down collide. And we're going to run that. There's a couple ways we can do this. We're going to make it the easiest way. We're going to run it 64 times because that's roughly how tall he is. We might also be smart to run it the Y speed amount of times because that's how the most amount of steps in pixels he can take on a down move loop. We're just going to do 64. All right, so we're starting this loop down collide 64 times. So now we actually have to do something on loop. So we'll say on loop down collide. Now we need some conditions here. First we want to know if he is overlapping a backdrop, because that is how this initially was called. So if he's overlapping a backdrop, we know he's in a backdrop. We need to move him out of that backdrop. So we'll set his position. It says Y coordinate to his current Y coordinate -1. So he is going upward. Let's copy this event and let's negate this. So what we were saying here is on loop down collide, and he's not overlapping a backdrop. That means we know that he had hit, he's been pulled out, he's no longer overlapping a backdrop. So what we need to do now is set the value of Y pos to its current Y position. What we're doing there is over here we were just moving him on the Y position, but since the engine keeps track of, moves the Y position of the object relative to the Y pos, after we moved him, we updated Y pos, so that when the loop runs again, he will be in the right spot. We also need to set the Y speed to 0, so he will stop. Sorry, that was X speed. We essentially want gravity to stop pulling him down. Let's test and see if this works. Okay, it did work. There's one more thing we can do, just to give it a little pizzazz. We're going to add a bounce. So what we're going to do, you don't have to do this, but if you want to, go ahead and follow along. We're going to set the Y speed to the value of Y speed. We're going to multiply this by 0.5, so every time it hits, we're going to cut it in half. We're going to take the whole thing, and we are going to put it in parentheses, and we're going to multiply it by -1, which is going to invert it. So that means that we essentially, when he hits the ground, we are going to cut his speed, his Y speed, in half, and then we're going to invert it so it'll go up. Let's see if it looks good. Let's check it out. Okay, so this didn't work because we forgot to stop the loop. We will go to fast loops, stop loop, and the name of the loop was down collide. The reason we have to stop it is because it is going to keep running and running that code. So it essentially ran this a ton of times and decayed that to nothing. There we go. So we have a bounce. But as you can see, he's kind of wiggling and waggling at the bottom there. We don't want that. So let's go ahead and modify this a tad. We're just going to add 1 to his X position here. Under Y pos, we're going to add it to X position +1, forcing him down by 1 pixel. Alright, that worked. Let's go ahead and test it with a different number and make sure. Let's modify that by 0.3 and run it. Okay, good. Let's go ahead and try one more thing with it, actually. We're going to throw in another backdrop. Alright, so let's throw this here. Let's make it an obstacle. Now we are going to move right and left. So we're going to delete this stuff where we had to subtract and add. We don't need that. We're going to do this through loops. So we're going to do the right first. We'll say repeat while right arrow is pressed. We are going to start a fast loop. This is going to be called move right. We're going to run that 1 time. Let's go down here and do an on loop. That loop is called move_right. So what do we want to do on move right? Well, we want to move it to the right. So we're essentially doing the similar thing we did above. So first we want to set the alterable value of x speed to the value of x speed plus our acceleration 0.1. Then we want to set the value of xpos to the value of xpos plus x speed. Let's make sure that's right. Set x speed to x speed plus 0.1. Set xpos to xpos plus x speed. And lastly, we want to update the position. We are selecting the x coordinate, and we are going to set that to the value of xpos. Okay, so that is what's going to happen on default, but we also need to do stuff if we collide. So we will do another on loop of it. It was move underscore right. And we're going to find out if we are also colliding with the backdrop, or overlapping a backdrop, sorry. And when that happens, we are going to run a loop, and we're going to call this one collide x, because we're actually only going to use one loop for the left and right collision. And we're going to run this 64 times, so we will need to stop this and prevent it from running its entire 64 loops. Okay, so let's go ahead and make that loop. On loop, and that was collide x. We need to find out if we are currently overlapping a backdrop, and we need to copy this whole event with Control-C, paste it with Control-V, and negate, because we need two events. We need one for overlapping and one for not. So on collide x, when we are overlapping a backdrop, we need to pull our doodly out of the backdrop. So set his position to his x coordinate minus, and we want to make this the reverse of the direction he was going. So we are going to do this by, in math and in programming, there's something called sine. And it would normally work like this. And then you have a value. And so sine 5 would return 1. Sine 0 would return 0. Sine -1 would return -1. I wish there was sine. There is no sine. We're going to do sine manually. So, so we are going to essentially get this guy out by 1 pixel. That's the idea. So we're going to do this way. We are going to get his x speed. We are going to divide that by the absolute value of his x speed. We need to make sure that we have the proper parentheses around this. Let me see. Wonk, that's good. Yeah, this whole thing needs to be in brackets. So what we're doing here then, this is getting us the equivalency of sine of his x speed. So it's just going to pull him out in the opposite direction of his x speed. Yeah, so that should work. That should function. All right, so that's what happens if he's overlapping a backdrop. If he's not overlapping a backdrop, then we need to set the value of x speed to 0, because we no longer need him to accelerate. And then we need to set the value of xpos to his x coordinate. So they are now matching. So x speed 0, xpos. And then we need to stop the loop. And that loop was called collide x. Hope that made sense to you guys there. I know that math might be a little bit complicated. It really isn't that hard. Just think about it. Like an absolute value is how far a number is from 0. So it's always positive, essentially. So if I had the number 100, the absolute value of 100 is 100. The absolute value of -100 is 100. And so if you were to take like let's say you had 100 and you divide it by its absolute value, that's 100. That gives you what? It gives you 1. So if you have -100 divided by its absolute value, which is 100, it gives you a -1. So all that's doing is giving us a 1 or a -1, allowing us to pull the pull the player out of the wall by the proper direction of 1 and having it be 1 pixel. I'm just saving on conditions. I don't like to have a lot of conditions. Anyway, let's check it out. Okay, that right collision worked. Now we need to set up a left move. So left arrow, we're just going to start a fast loop, and we're going to call that move underscore left. We're going to run it 1 time, and then where's move right? I'm going to copy move right. I'm going to rename it move left, and I'm going to modify some stuff because it's going to be pretty similar. Okay, so we're going to set the x speed to the x speed minus 0.1, update the position, and yep, that's all the same. Now we got to do some we need to find out if we're colliding. So a new event on loop, move underscore left, and we need to find out if we're overlapping a backdrop. Okay, when that happens, we're just going to run the loop collide x 64 times. Okay, let's go ahead and check it and see if we can collide right and left still. Go right works, left works. So we now have a pixel perfect collision engine using subpixel movement. All right, so the last thing we need to do is allow the player to jump. So we're going to do that this way. We're going to go ahead and throw in a new condition, our new event. We're going to say if the player has pressed the space key, and we're going to find out if this, a flag, we're going to look for a flag. So we're going to look for flag 0. We want to know if it's on. We're going to pick on because it's off by default, and in case he's in the air, we don't want him to be able to jump initially. So if it is on and we press space, what we're going to do is set the value of y speed to something in the negative. So like -4. So now we just need to make sure that whenever he hits the ground, that it turns on y speed. So let's do that now. Let's look for on down collide, and he's not overlapping a backdrop. That is the point at which we bounced. That means we have pulled out of the ground, and we are ready to, in that loop, we are going to set that flag on so he can jump again. Make sure that the order is correct. We didn't want to stop the loop until that flag is turned on. All right, what else? When we jump, we obviously need to set the flag off so we can't jump again. Okay, can't jump in the air, and I can jump now. All right. So there we go, guys. That is a sort of a platformer engine using subpixel movement. At this point, you should understand subpixel movement pretty well. But if you don't and you have any questions or comments, please leave them down below. And if you want some more robust help, I have a Discord channel. You will find it in the description. Please join our Discord and hang out with us. And if you guys need any help, there's lots of people there who are willing to help you out with any bugs or issues you might have. And we can all just learn together to become better coders and game designers. So, as always, guys, thank you for watching, and you have a fantastic day. See you in the next video.